Hi, my name is Sudarshan. Welcome to my channel EasyML. In this video, we will see how the random forest model is built. Let us start with our predicted variable. Here, we are predicting gender, which is a categorical variable. We will build the random forest model on this sample training dataset right here. Recall when I explained regression models, I had mentioned that the predictive model will be built on the training data and the accuracy of the model will be assessed on the testing data. For those of you who need a refresher on training and testing data, please click on the link provided below. There are two important steps to build a random forest model. Step 1 is to keep taking a random sample from the n observations in the above training data. Step 2. Well, if we have v input variables, then the analyst must specify some number k such that it is less than v. For instance, in the above sample data, we have 3 potential input variables that can help predict gender. That is height, weight, and age. So our v is equal to 3. Hence, we can specify the value of k as 2, since 2 is obviously less than 3. Now, by deploying these two steps, we will construct a decision tree model on various cross sections of the data. So, from the n observations in the training data, we take a random sample. Let us call this sample as sample 1. Then, from the 3 potential input variables in the same data, we take any 2 because we have specified the value of k as 2. Here, out of height, weight, and age, I have chosen only height and weight. So, based on sample 1 and the input variables height and weight, I will build a decision tree to predict gender. Let me call this decision tree as tree number 1. Now, again from the same n observations, I take another random sample. I will call this sample as sample 2. Then, from the 3 potential input variables, I will now take height and age. Therefore, based on sample 2 and the input variables height and age, I will build another decision tree model to predict gender. Let us call this tree as tree number 2. Again, from the n observations in the data, I take yet another random sample. I will call this sample as sample number 3. And from the 3 input variables, well, this time I will choose weight and age. So, based on sample number 3 and input variables weight and age, I will build another decision tree model and I will call this tree as tree number 3. Here, we can see that we have built 3 different decision trees from various cross sections of the training data. Recall from the previous video, we concluded that the decision tree changes because of the change in the number of observations or a change in the input variables. Here, by change in the number of observations, we are referring to the various samples that we have taken, that is sample 1, sample 2 and sample 3. And by change in the variables, we are referring to the various combination of variables we have taken here, that is height age and weight age. If I combine all these 3 trees that I have obtained, I get a random forest. Although each of these trees are built on various cross sections of the data, they will predict the same thing, that is gender, as obviously gender is my predicted variable. Now, let us say I pass the testing data through the random forest model that contains these 3 decision trees. Each of these trees will predict gender. Here we observe that for a particular observation in the testing data, tree 1 has predicted female, tree 2 has predicted the gender as male, and tree 3 has predicted the gender as male. Because the majority of the trees have predicted male, the gender of the observation in the testing dataset is predicted as male. Therefore, the advantage of random forest model is that it builds multiple decision trees on smaller cross sections of the data to enhance pattern recognition, thereby increasing the accuracy of the model. In the next video, we will see how we evaluate the accuracy of the random forest model. So stay tuned. Thank you.